Hello, folks. This is a video tutorial for homework 3. Now, you may recall this problem. This assembly, solder crank assembly, was actually an activity which was back in week 2, activity SD00. And you already created that assembly. And now you're going to put some physics into it. We are told that this link AC is turning at the speed of 60 RPM. But the actual rotation direction doesn't matter. And you're asked to do a few things. Obviously, create the mechanism and then find the path or the trace of the point D, which is exactly halfway between these two centers, and then plot the magnitude of the linear acceleration of the block, or not the block, the magnitude of the linear acceleration of the point D, okay? Store it in the graph, and right. And what I'm also gonna do, although I didn't ask for it, but I'm gonna do that here, which could have been asked. Plot the for example, X, let's see now, plot uh, the graph, which is the velocity of the point D versus the acceleration of the point D, magnitude of the velocity versus the magnitude of acceleration. Please keep in mind that here, it just happens that you're asking for a plot of the magnitude of velocity of the point D as a function of time. But what I'm asking you to do, also plot the magnitude of the velocity versus the magnitude of acceleration. Okay? All right. Let's go ahead and do that. We already know that this thing works. As a matter of fact, if I go to mechanical design, assembly design, and check it out. For example, move, let's say with respect to the constraints, and rotate about this axis, things better move the way we want. So this actually works fine. Okay. So now we're going to close that. Now we're going to go to, before I do that, let me create a point exactly halfway between the center of this and the center of that, because that's going to be the point D. Okay, so let's go ahead to, what is this? This is Conrad. Go to the Conrad, which is, see, this was a C, this is CB, I believe. CB. Let's see now, CB. Okay, so let's go ahead to the Conrad and double click. We are in part design. So let's see now. Let's get a point, a point, a point which is halfway between these 2 points. But let's create these 2 points first. So let's say that we say center of a circle, center of that circle, a point has been created there. And then another one. Where's the other one? Another one of this circle. No, cancel that. Try it again. Another point, center of a circle, that circle. You may have to zoom in. Okay, right there. And now a point exactly halfway between these two. We can do that. So we're going to go between this point and that point and exactly halfway location, which is right there. So this is going to be the point D right there. Okay, good. So we are out of that. Now we're going to go to digital mockup, DMU kinematics. Get the magic wand out. New mechanism. Mechanism number 1. Auto create. And OK. And let's see what kind of joints we've got here. Under applications, It's a single degree of freedom system. We know that. We have a prismatic joint, which is this block going up and down that track. You have a revolute between the base and the crank. So it's this one. This is revolute between the base and the crank. Cylindrical between the block and the conrod. Cylindrical right here between the block and this connecting rod, and a revolute between these two. So we want to make this thing kind of as the angle driven command. So double click on it. You say angle driven. Let's say between 0 and 360. Okay, mechanism can be simulated. That's good news. Can we do that manually? Yeah, sure. So simulation with command, as you turn this thing around, this thing goes 360 degrees. Good. Reset. Good. Okay. Now, first of all, you want to create a replay. So remember, to create a replay, first you have to create a simulation. Right there. Create a simulation. Mechanism number 1. You say, okay. Now drag this thing all the way to the end. Insert. Don't use 1 because 1 will quickly jump to the end. Good. So can we check it out? For example, if you go to simulation, uh, you can always check it by double clicking on it. You see that as you move this thing around, this thing moves. That's very good. Now, why we created the simulation? Because we want to create a replay. So there is a replay. You need a simulation in order to do the replay. Don't use 1, but it's a replay. Yeah, say okay. There we are. And I can always check your work by going to the replay and play this thing without going to a simulation. So you can see that fast. This is even faster. So it does work. Okay. So let me stop this thing. Rewind. Good. Now, why we created the replay, the other reason is that we want to create the trace of that point. So let me go ahead and click on the trace. There's the trace. Element to trace out is the point that we created over here, this point halfway between these two. And if you say product, it will actually make it a new part. But if you go and select, instead of the product, you select the base, then it jumps to the reference point. So the part will not be created, but it's going to be part of that assembly you can hide. Now, notice that in the statement of the problem, I say generate the path or the trace of the point D located exactly halfway between this and bring it into the assembly. Why I put down bring it in the assembly is that some people may not pay attention to the fact that it's going to be created as a separate part, and then you have to save it using file save management in that same folder, and then you insert existing component. Okay, but if you did what I just did, a part will not be created, but it's going to be placed right in the product, which is perfectly acceptable for us. And then we say, okay. Incidentally, number of steps here, the more you have, the smoother this is going to be. So let me make this thing maybe more 50, just so it looks nicer. Oh, maybe that cannot be changed. I didn't realize that this is set by. In all likelihood, it's somehow related to this. Number that we set here, remember we changed one. In all likelihood, it's related to that, but that's okay. 26 will be fine. Fine. There we are. The 26 is the number of points here. If you want to change it more, probably there is a way of doing it, but right off the bat, I don't know what it is. So if you play it, if you do a replay here, or actually, let me do the following. If I go and manually move this, notice that that point D is actually following that path right there. You can see that. Okay, reset. Good. The next thing we want to put some physics into it and plot certain thing. Now, in order to plot some certain thing, you have to actually set a speed and acceleration. You click on it, sensor, speed and acceleration sensor. So the reference product is that base, and the point that you want to get something about is that point D. Okay, that point D that I created. Good. All right, so we have created our speed and acceleration sensor. That's good. Now we're going to put some physics into the problem. So we go to f of x, click on the mechanism, and this is where you specify the physics, okay? So you want to say this angle, add the formula, equal to, remember 360 degrees, 60 RPM is 1 round per second, or 360 degrees per second, or let me try, yeah, so 360 degrees per second, DEG underscore S times time. Now I told you that you can write here 6.18 rad underscore, well, actually you can also do 60 R, you may be able to do 60 RPM. You can try that yourself. So 60 RPM is 1 round per second, and 360 degrees per second times time. Double click, and we say okay. So we have a physics into the problem. Okay, and now we're going to do simulation with laws. Activate sensor. What are we asked to do? We are asked to plot, first of all, velocity of magnitude of the velocity of that point as a function of time, magnitude of linear acceleration as a function of time. So let's do that first. We're going to do linear acceleration. This is the magnitude, no x component, no y component, no. It's a linear acceleration. That's the magnitude, and it turned into yes. Okay, and I will ask for something else. The only problem is that remember that I asked you to do later. I'll come out and do it later. So move this thing out of the way. And this is over how many second interval? Let's check out what the problem says. Simulated over, it doesn't tell you, but I'm going to do that over, because 2 rounds of this, I'll make it 5 seconds. How about that? I'll change this thing to 5. Say okay. Now play it 5 times. You go here, graphics. That is not correct. Linear acceleration. Hang in there. This is definitely not correct, because it looks like it's giving you 0. So let's go ahead and find out what the issue is. You know what? I have a feeling that I did not pick that point. Yeah, that's one of the fixed point. Cancel that. Close that. Close that. I think it has to do with that speed and acceleration. This, oh, sorry, not there. So, yeah, you see this one, when I selected, when I activated, selected, when I created this speed and acceleration, I selected a point here. I did not pay attention. I probably selected one of those fixed point that I created. So let me cancel that. Unfortunately, I have to bite the bullet. I have to delete this. Okay, let's do another one. For the reference product is this. For the point, I'm not going to select it from here, because that point that I want is actually hidden below that. So I'm going to go to my, was that connecting rod? Yeah. And it's this point, that point, point number 3, this point. So good. So let's go ahead back to the simulation with laws. Okay, let me rewind this thing. Activate sensors. Let's go ahead and select that point, linear acceleration right there, turned into yes. Okay, move this thing out of the way, play that 5 times, and graph. There we are. When I pick that point, it's actually one of those 26 points on the graph that is fixed in space. The point that I wanted was actually behind that. It was hidden, so I could have hidden those points. And but anyway, you get the picture. Now What's the rest of the problem? How do I know that you have done this thing? First of all, move out so that I can see your units. Notice that it says in the units inch per second square, inch per second square. And then this is time. Use screen capture. For me, it is function print screen. You do it any way you want. Just make sure you give me something that I can look at. I know that you have done it. Okay, so that's good. So I go to a Word document. There we are. And I'm going to paste this thing. And I write some description here. Magnitude of velocity of D versus time. Make sure you save this thing. File, save as, in that folder. And that folder is on my desktop. And I called it, yeah, so I think it's in my folder here somewhere. Must be there. Mechanism design, week 3, homework, right in there. And I say, okay, so let me go check. Make sure that I did not forget. I'm done with this. I can minimize that. Let's go ahead here, right here, magnitude of velocity of d versus time. Because on your test or final, you have to give me the product, all these plots. Sorry, the product, all these parts. If you had the trace, your trace. I don't because of the way I did it. And this file, magnitude of velocity of d versus time. And there's more to it. I've asked you to do something else. I've said that, okay. So what I do is I'm going to rewind this thing. I want the velocity of that point versus the acceleration of that point. Okay, so I already have the velocity generated, linear acceleration generated. Now I need the linear speed generated. Okay, and I rewound and make sure that you clear the history tab, clear the history, so that we start fresh from the beginning, and then you plot it or run it. Okay, now if you go to graphics, you see that I get both of them. One of them is the old one. This was added to. I don't want this. What I want you to go to options, customize graph, add, give me velocity, linear velocity, which I asked for it, linear speed versus linear acceleration. Linear acceleration. Linear speed versus linear acceleration. And I say okay. Select this curve 1, close it, and then say graph. There we are. One of the axes is velocity of that point. The other axis is acceleration. This is the acceleration. This is velocity. So you get a curve like that. Not versus time. Now make sure you screen capture this function, print screen, select this. That's how I do it. That's how I print screen capture. If you have other ways of, make sure you know how to do it on the computers in the lab. Okay, so I go to that folder which was here, open that Word document, and then I go and add it or paste it, and I call this thing. You can say this is velocity, magnitude of velocity. Say magnitude of velocity, magnitude of velocity versus magnitude of the acceleration versus time versus. Save this, close it, and remember, when you upload your work, give me the product, give me all the 4 parts, give me the magnitude of the velocity versus time, and which in it has that other thing too. If you don't give me this, I have no idea whether you have done it or not. Okay, this was your homework, and the only addition to the homework is that second plot that I asked you to screen capture and give it to. Now, on reset, close, and I'm going to save all of this, and good luck.